This is an example of differentiation and a method that's sometimes referred to as function of a function. Now, what I've got here is a bracket to the power of 8, and it's too big a power for me to consider multiplying out the bracket to getting individual terms. So obviously we need a method of doing this, and the way to attack this is to think of this bracket as defined by a dummy variable, and we're going to use the dummy variable u. So let u equals 2x plus 3. Now this means that this expression would become y equals u to the power of 8. So I'll divide my page a little bit now. We're breaking down the problem into two different things. I can differentiate y as it's a function of u with respect to u, and u to the 8 becomes 8u to the power of 7, and I can equally differentiate here du dx, and du dx, as this is a function of x, 2x plus 3 becomes 2. Now the chain rule allows us to pull these together to give us dy dx, and we do it as follows. Dy dx is dy du multiplied by du by dx. You can think of the du's as cancelling and leaving you with dy dx. Now in this situation, my dy du is 8u to the 7 and du dx is 2. So I've got 8u to the 7 multiplied by 2. I combine that now to give me the answer. Dy dx is 16u to the 7. We can't give our answer in terms of u because it was our invention. So we go back to the original definition, which was 2x plus 3, and then that will be to the power of 7. The introduction of a dummy variable here is one that is used in mathematics quite a bit, and it's a means to an end. It's one that you should practice.